Hi everyone! After the theory about the installation of the PID in a single boiler espresso machine, today I'm going to show you how I made the implementation of Rancilio Silvia. If you're installing a PID, I really recommend going through the whole video because there are lots of mistakes that you can avoid, and a lot of things, for example, about the sequence of assembly, the sequence of connections, where you can install some of these components to prevent issues with your future modifications, like lack of space for the pressure gauge installation or lack of space to access some screws and to connect the wires. And especially if this is the first time that you're installing a PID, learn from my mistakes. I think it's gonna work and you're gonna save a lot of time and money. I'm also showing how you can test and make sure that you did everything right and that you won't create any short circuit. In the end, you will also see how to fine-tune your settings or to use the auto-tuning function. And in www.espressohackers.com, you will find a list of all the components, tools, and consumables that I used in this mod. I checked the specifications and I put some comments on what are the types, the specs for each of the components that you need to buy, dimensions. So take a look. And in the end of the procedure, there's a table with the settings for PIDs installed in some machines that I could get the information from other users. You can use as a starting point before fine-tuning yours, or just use the auto-tuning function. Okay, so first thing you need to do is to mark the connectors, where each wire goes where. If you see, it can be pretty confusing. Here you have, for example, the extraction button. You have two wires coming out of this button and two here going in this button. And in the front, you will see that you have two other buttons. One is for the hot water, the other for the steam. More to the left, you have the power button and then the LED. Plus, you have the two thermostats. One is the extraction thermostat, the other is the steam thermostat. And you also have another one for protection. And you have two wires on each. I also mark the side that they are connected. If you can see here, there are two bullets that should show me what is this side. It's not relevant in the case of thermostat. You can see that here I inverted. Then you have wires going to the pump. There's a little component here that is the protection for the pump that should go underneath this small hole. And in the front, you have the solenoid valve. You also have some wires in different colors that I disconnected and marked each connector here. You have a ground attached to the boiler. After marking all the wires, what I would do is I would test, well, I'm supposing that you have a different machine, okay? If you have a Rancilio Silvia, you will see the schematics. But if you're installing the dimmer in a different machine, you need to build your schematics so that you know where every wire goes and what should be working or not when you press one or another button. Okay, so now I'm gonna show you how to do this test. All right, we're gonna use the multimeter, and it's gonna be the same continuity test that I made in the dimmer mod installation. You can check there how to use the multimeter. This is the heating element. This will have to be activated by the PID, and it's currently being activated by the extraction button and the extraction thermostat and the steam thermostat. I'll keep the steam thermostat so that you can steam using the thermostat and not the PID. Some people prefer it's more, I don't know, convenient maybe. And I'll only use the PID to replace the thermostat for extraction. Here we have the thermostat that is going to protect the circuit from overheating. If it overheats, it will cut the power to the rest of the circuit, and we're going to keep it. Then we have the energy that will come into the SSR and that will go out to the heating element. This is the component that will actually deliver the power to the heating element. The PID cannot send the energy itself, and it's this component that will switch on and off whenever the PID wants to send the energy to the heating element. And here is where the PID will control it. So when the PID is sending energy here, it will close the contact and the power will flow from here to here, and you will have energy flowing to the heating element. So now that we know what we want to test, one thing that is important to mention. For this test, you need to disconnect the pump. And why you need to do that? Because the pump is an electromagnetic device. When you're testing, it will show continuity when you are not expecting to see. Same for the solenoid valve. It also has this it's also an electromagnetic device. So let me disconnect also one of the wires that goes here in the solenoid, and now we are ready to test. Let's set it to continuity or to the maximum scale of resistance. Now I'm gonna use the continuity test so that you can hear the noise. Okay, so the machine is off, unplugged, and now since it is off, you shouldn't see any energy flowing to the heating element, right? I'm gonna test both pins. No signal, no signal. If I turn the button on, no signal, and yes. So this left pin is delivering energy here. So it's coming to this end whenever the machine is on. The other wire is also on. So this is what we expected, right? If the machine is on, the power will be delivered to the heating element until the temperature is achieved, and then the extraction thermostat will cut off the power because the temperature achieved, I don't know, 95 degrees. When the temperature goes below the 85, probably, it's about 10 degrees below, then it will switch on again and will deliver power to the heating element, and it will heat up again. This is where I want to connect my SSR, the input to the SSR, okay? Remember that I told you to check the schematics before making the modifications? Let's see what happens when I turn on the steam button. You will see that I have set the temperature for 20 Celsius degree. You will see that it will not go beyond 24, and it is going up to 24 because there is some inertia in the system, and I just changed the temperature. Let's increase the temperature now to 100 Celsius degree to see what happens. You will see that the temperature was being limited by the PID and not by the steam thermostat. So now you can see that the temperature is rising again. So let's understand what happened in this installation. I put in purple so that you know what I did in my installation. And that's why I recommend you to check the schematics before making the modifications. So I thought that I could interrupt the connection between the overheat protection thermostat and the heating element, and I would send this phase to the number 1 in the SSR. Then from the number 2, I would send it back to the heating element. I made a jumper to bypass the brew thermostat so that when we turn on the machine, the energy would flow through this end, would pass by the steam thermostat and would reach the other end. But what is the issue? If I want to steam using the steam thermostat, when I press this steam switch, okay, the energy will flow to the steam thermostat, and after the steam thermostat, it will reach this end of the heating element. However, the PID, if it is set for 90 degrees, for example, when it achieves 90 degrees, it will stop sending electricity to this other end. So your steaming will not work if you don't change your PID, the set temperature, to 120, 130 Celsius degrees, because the other end will be interrupted as soon as it reaches 90 or whatever is your brew temperature. So then I changed it to this configuration here. Then I'm using the SSR to bypass the brew thermostat, but this phase will be delivered to this end, right? So it will feed into the steam thermostat so that they are both in series. And then when I decide to steam, okay, the SSR will stop sending electricity when it reaches 90 Celsius degrees. However, if I'm steaming, the energy is flowing here to the steam thermostat, and then it will reach this other end of the heating element, and the black wire will be connected to the other side, so it will continue heating until it achieves the steam temperature. So now I'm gonna make those corrections in my machine, and I'll continue the video. All rebuilt now. Then the jumper was removed. The red phase is flowing to the number 1 in the SSR. The number 2 in the SSR is going to the extraction thermostat, the gray wire, and after, to the steam thermostat, and then from the steam thermostat it goes to the other end of the heating element. We have power delivered to the PID here. So I made this, let me remove it. So this is the piggyback connector that I'm putting here in the power on button. So when I turn the machine on, this connector here is sending the red phases to the rest of the machine, and the piggyback connector allow me to send the energy to the PID. For the black phase, I prepared this piggyback connector that will be attached to the exit of the protection thermostat. Let me try to show it here. So here is the protection thermostat, here is the connector. So I'm putting the piggyback connector here. Then the energy will be sent both to the PID as well as to the heating element. Okay. So let me connect it back here. Okay, so this is the second piggyback connector, and it's sending energy here to the heating element and also to the PID. All right, and what is going to control the temperature is this terminal here. So the energy is flowing to this terminal either through the steam thermostat, because I left it here to control the steaming, or when I'm brewing, the SSR is sending the energy through this wire to the gray one and feeding the steam thermostat. Then we have the number 3 and 4 in the SSR that is sent also to the PID. So I put the SSR here, so it's already there. I will not remove it, but I don't think it's the best place to install it. I think next time I would place here in the bottom. It's important for you to simulate where you want to install, because later if you decide to put a pressure gauge, for example, you need to have space to drill a hole if you want to drill a hole on the panel, or if you want to make the dimmer mod and you want to install the dimmer on the side of the panel and you want to make the hole here, then you need some space. And here we have the thermocouple type K. It has a single blue wire here, but on the other end we have the terminals, 2 connectors, blue and red, that are connected to the number 6 and 7 in the PID. You have 2 options. You have the threaded thermocouple that you can remove one of these screws here, and then you just fix the new sensor, the thermocouple. You can use type K or type ET100. This is type K. So this is the position that I decided to install the PID. Maybe not the best. It's a very common place. You don't have much space to install it here because on the back you have the screw, sorry, you have the nut that connects the steam wand. Maybe you can put it on the side. Maybe I can mount a top box. Only for this demonstration I decided to put it here, but it's temporary because I'm gonna make the Gadrino mod. So I used double side tape to fix it. It's okay. Maybe you should just check if yours are resistant to heat. Some of them are better. A small detail for you when you are looking into your machine and deciding how you're gonna power your PID. I wanted to have it on only when I press the power button, right? So I checked where the energy would be delivered, where is the out of the power button, and then I connected to the PID so that I don't have to unplug it from the outlet if I want to have the PID off, right? We don't want the PID on all the time. So this is the test that I made, and that is why I chose to bring the energy from this position. The other wire that is going to the PID to power on is this one, because it's after the protection, the thermostat that will protect the circuit. So I'm still having the benefit of using this protection. When it overheats, it will cut the power for all the electrical elements here. Now let me show this PID. So it has the instructions on the side. You have the screws for the SSR, the thermocouple, and to feed, right? So here I will connect the red and the black wires that will turn it on when I press the power button. Here on the side you can see that the number 10 is for the positive and the number 9 is for the negative. Remember that the green is the negative, the yellow is positive. So I'm gonna fix these two wires, the green in the 9 and the yellow in the 10. Then the small detail for the thermocouple is when you have a PT100, you're gonna use 6, 7, and 8. When you have only a type K thermocouple, you're gonna use 6 and 7. In my case, I'm using a type K, and then I'm gonna place the red in the 7 and the blue in the 6. And the thermocouple will be the last one to be connected because the wires are very thin, they're more delicate, and I reduce the risk of damaging it, okay? These wires that will go to the PID, I'm gonna send it to the front, to this hole here. Depending on your machine, you will have to find another place. Oh, there, now a small detail. The enclosure has a hole for me to pass the wire inside. So we need to do this first, right? And then we'll connect the PID in the front of the machine. It sounds a bit stupid, but this is the kind of thing that you forget. I forgot sometimes. Now we'll connect again. First the power. Let me bend the connectors first, so that's easier to fit inside the machine. 90 degrees. So number 1 and 2, red and black, yellow in the 10, red in the 7, the thermocouple, with blue and the 6. Now it's time to place it inside. Make sure your terminals are not touching this aluminum case, or you're gonna have a short circuit. So let's test and close the machine. For the test, I'm using the continuity function here, so it's gonna beep when it's working or not. So my machine is unplugged for safety reasons, and I'm gonna test simulating the machine working. So first thing, let's see if there's any short circuit. Well, let's disconnect the pump and the solenoid valve and one of the terminals here in the heating element. So machine on, no short circuit, that's good news. Now let's see if there is any energy being delivered to the pin number 1 in the SSR. Yes. Okay, only the right phase. Let's test if the PID is working. Only the machine is on, so there's no energy flowing to the yellow wire because this is controlled by the SSR. If I'm brewing, we won't see energy being delivered here as well because the SSR is off. Now hot water button, nothing as well. Now steaming. When I'm steaming, the energy is being delivered by the steam thermostat. Okay, so let's close the machine and power on. I can't forget to connect the pump, the solenoid valve and the heating element. Now let's make a test here. Let's see if you're gonna have an accident or not. Yes, it's working. Nothing exploded. Okay, I set the PID for 50 Celsius degree. Now let me turn this machine to the side. Now you can see that the LED is blinking, so it is heating the boiler. I set it for 60 degrees, not so hot. So it's gonna be a bit slow, but yes, it's heating. I can feel it. Now, let's set. I'm gonna turn the machine to the side now. Okay, so the temperature is in 35, right? So let's set a very low temperature. Okay, so now it's going to stop heating. You see, it's not blinking anymore. Neither the LED in the panel, neither the PID. So if it's not blinking, it means that it's not sending signals to the SSR to heat the boiler, and the temperature is not increasing. Now, if I set to 10 degrees, it's not gonna heat above 10 degrees, but if I set to steam, you can see that the light now is on. I don't know if you can hear the noise, but the boiler is heating and the temperature will increase here. So the temperature is increasing, not because the SSR is working or the PID, but because the steam thermostat is working. I'm gonna allow it to heat up to the steam temperature so that you can see that this is another test in reality. I don't want the brute thermostat to stop it from working. It won't, because it's disconnected, but I'll wait until the steam temperature is achieved, because well, maybe I disconnected the wrong thermostat. I think I'm using the steam thermostat, but in reality I made a mistake and I'm using the brute thermostat. So let's check if it's gonna achieve 120 Celsius degrees. Reminding that we have a 14 degrees offset here, 14 or 13, I don't remember. So the temperature that is gonna be shown here will be different than the temperature that the steam thermostat will stop heating. So the steam thermostat stopped in 135, so it's probably 148 in the boiler, a bit high, but okay. So all good, the machine is working. Let's now close the machine. Let me show you some of the adjustments that you can make. So if you want to access the settings, you're gonna put it 89, and then you have this interface where you can set, for example, the offset. I'm gonna show you how to measure the temperature, and then you can put the offset in this parameter PSB. So mine is set for -14 because I was measuring the temperature that was being displayed and the temperature that was showing. So basically when the temperature here was showing 39, I was seeing 25 in the group head. I measured with my temperature probe coupled to my thermometer, and it was showing 14 degrees less. So I went to that menu and I adjusted PSB to -14. How you're gonna measure? You set your value, your target value, to your desired temperature, for example 95. Let it stabilize with the portafilter here in position. When it hits 90 degrees or 95, let's say that you set for 90. When it hit 90 degrees, let it heat for maybe 15 minutes more, 20 minutes more, so that you make sure that the group head and the portafilter are heated. Then you can grind some coffee as you would for the 30 seconds shot, 1 to 2 ratio, and then you start brewing. When the temperature stabilizes, probably after 5 or 10 seconds, you will see a temperature more stable here. If it is not the 95 that you set, and if it is, for example, 80, you adjust the PSB for -5, for -15. Now the other adjustment that you can make here is in the menu that you access, putting 36 here, right? So you have P, that in my case is set for 1.0. If you use REX C100, it's gonna be different, okay? And this is for Silvia's, probably very different for Gaia and other machines. But I tried to put something between 1 and 2 here to start. Then in the I, it is set for 400. Maybe you can start with 300, I don't know. And the D, you can start with 0. The D will put the minimum as possible. First you stabilize the first 2 parameters, then you change the D. The D is the last one to be changed, and I would always keep it to a minimum. I will not explain the theory of PID here, but you also have an auto-tune function that I'm going to show you later how to do it. And supposing that you made an adjustment, you just let the machine cool down and you turn it on as you would normally, and no matter how long it takes to achieve your desired temperature. If it is 95, for example, and it is taking 2 hours to get stabilized, something is wrong, right? Then you will probably change your parameters. How would you adjust? It's trial and error. I would always keep the P between 1 and 2 maybe 1, the lowest. The P is the how fast the PID will try to achieve the set temperature. The D, if you put it too high, it will have more overshoots. If you put too low, it will take too long to achieve your desired temperature. So maybe you can start with my value, and then you can decrease if it is overshooting too much. And then the D, I think something between 0 and 20 should be fine. 0 means that it's only proportional and integral control without derivative. So maybe between 1 and 10 or 1 and 20. I would try maybe 5, then 10, 15, depending on your response. I would put something in between the 5 and 10 or the 5 and 15. If you're using the PT100 sensor, you also have to change this parameter. So if you enter into the 0089 menu, then you will have this first parameter here, and you will have to change either to PT 10.0, which means that you're gonna measure to the decimal point of degrees, or here is the measurement by every 1 degree, right? Mine is type K. I'll keep it set as K here. The K is like an inverted 4. You can see here. Okay, what if you want to use the auto-tuning function? How would you do that? You will press here until the AT button starts blinking. So if I press here, the AT will start blinking, which means that the auto-tuning is started. You will let it try to adjust it till it achieves the optimum set. So that was it for today. If you have any doubts, leave any comments below that I'll try to answer to the best of my knowledge. If you didn't install the dimmer, the video is already available. And if you want to install the pressure gauge, this is the next mod that I will make available.